Welcome to Simplifying AI, an explainer series from OpenX, designed for both the people who run media and the people who experience it. In each episode, we'll break down key elements of this fast-growing technology with one goal: to make AI more understandable for everyone. Previously, we looked at how AI understands language through natural language processing. In this episode, we'll explore how it thinks. Neural networks are the foundation of modern AI. They learn patterns, make predictions, and improve with every piece of accurate data they process. Big emphasis on accurate. More on that later. They're inspired by the human brain, but built on code and mathematical calculations. Picture this. You upload a photo with your friends. Your phone instantly groups it with other photos of those friends. No tags, no labels. It just knows who's who. Or when your favorite streaming service recommends a movie you didn't know you'd love. Behind both moments, neural networks. So what exactly are they? Neural networks are systems designed to recognize patterns in images, sounds, or text, and use what they've learned to make decisions or predictions. At its core, a neural network is a layered decision maker. It includes an input layer that takes in data, an output layer that produces a result, and hidden layers in between that do the heavy lifting. When a network has many of these hidden layers, allowing it to learn more complex patterns, it's called a deep neural network. Each connection between neurons has a weight, a number representing how much one piece of data influences another. The network takes in data, multiplies it by these weights, adjusts the results, and passes the information forward. That's forward propagation. If the result is off, say it labels a circle as a square, the network compares the prediction to the correct answer, calculates the error, and adjusts. That's back propagation, feedback that teaches the model how to get it right next time. It's not all that different from how people learn. Think of a child learning to tell the difference between cats and dogs. At first, they get it wrong, but over time, they start to recognize key features: tails, ears, fur patterns. Neural networks do the same thing, only at a scale that's hard to imagine, learning from thousands or millions of examples until they can spot the right pattern almost instantly. Neural networks quietly power much of the technology we rely on, unlocking your phone with facial recognition, filtering spam from your inbox, and predicting what you'll type next. And when it comes to curation, neural networks help dynamically match ads to the right content and audience, analyzing millions of signals in real time to understand context, relevance, and brand safety. Training these systems takes time, energy, and massive amounts of accurate, high-quality data from trusted, and more importantly, permissioned sources. That matters because indiscriminate scraping, automatically pulling data from the web without clear permission or context, can introduce errors, bias, and risk, and it's not sustainable long-term. Without licensed, high-quality content, models face lower quality training, regulatory pressure, and strained relationships with the publishers and creators whose work powers them. While misuse or poor training can introduce the risk of disinformation, responsibly trained neural networks can be transformative, enabling precision, personalization, and automation across industries, from media and marketing to healthcare and entertainment. Deep neural networks are the engine behind what comes next: large language models, or LLMs. In our next episode, we'll explore how LLMs build on these same principles to generate language, write code, and help you create your next big idea.